Hopefully nobody else is coming. So today we are going to speak about Camel K and the way it makes it possible to do fast builds and redeployments on Kubernetes. My name is Peter Palaga. I work at Red Hat Middleware. You could see me yesterday, and I have shown very similar slides, so a bit of repetition, if you saw it already. I spent most of my time developing and maintaining Red Hat Fuse, mostly or mainly the Fuse on EAP and Wildfly Camel. I did the same thing for JBoss EAP and Wildfly in the past. In my free time, I like hacking in build tools such as source dependencies for Maven and Gradle, and I created an implementation for editor config for Maven and Gradle. So this talk has two main parts. The first one is a general Apache Camel intro, and the second one is about Apache Camel K. So who of you knows Apache Camel? Nice, very nice. So don't think you will get bored. This will be very fast, and maybe you learn something you haven't heard yet about Apache Camel. So Apache Camel is quite old. Is more than how many? 11, 12 years old now. It's big. From several points of view. It's one of the biggest Java projects on GitHub in terms of lines of code. It's quite hard to import it in IDEs. It's hard to work with it because it's so huge. But it's not only a lot of code, it's also a lot of people and a very lively community. In the whole history, there are 466 contributors. There are 2,500 stars on GitHub. There are 3,300 forks, and there's more than 1,000 subscribers of the users' mailing list. So even though the project is quite old, it's still very, very healthy. What Apache Camel does, for those ones of you who never heard of Camel before, it's an integration library. The main task for an integration library is to exchange data between two or more software systems. So let's have a system A and system B, and there's some data in system A that needs to be transferred to system B. And for that purpose, we first need some sort of connector that understands the system A, is able to pull the data from the system A, and then we need the same for the system B, so that we are able to push the data into the system B. And this whole process, or the parts which are needed to do this transfer, is called root in Camel speak. We will hear this term root several times today, and this is basically what it means. Apache Camel is based on a general concept called enterprise integration patterns. There are many of them. This is just a small selection. There's a book that is, I think, called exactly like this, Enterprise Integration Patterns. The book appeared around or shortly before the time that Camel was founded. The book is still sold, I think, and there's a website that basically hosts the same content as the book. So if you are interested in that topic, you can visit it, and you don't need to buy the book. So what needs to be said here, these integration patterns do many things with the data that gets transferred from A to B, right? There are things like splitting and transforming and I don't know, mapping, whatever else you can imagine. I will show some basic examples today. Which is what is very important, or why Camel is so successful is the number of the connectors of those components that are able to speak with various kinds of systems. And there's this many of them. It's the number is around, it's more than 280. Some of them are deprecated, and this is the full list. For your convenience, I have grouped it in this smaller group. So there are things like reading and writing various file types, such as plain text, XML, and JSON, and CSV, and you can also read and write Microsoft Office and Open Document, Excel tables, and things like that. Then you can read and write protocols such as AMQP, DNS, whichever you can think of, as well as IoT protocols, which is very important today. Also things like REST and gRPC and Git. Then there's lots of support for public cloud providers. You can read and write S3 buckets and Kinesis and SQS on Amazon Cloud and similar things on the other important cloud providers. Then there's good old enterprise systems such as JDBC, SQL, JPA that you probably know if you are Java developer, CDI, AGB, and whatever. You can read and write most common caches, not only these ones, but probably all important caches that exist, including Ignite and Hazelcast, Infinispan, Redis, and so on. All kinds of databases. If JDBC is not enough, there's Cassandra and MongoDB components for your convenience. Then there are many connectors serving public APIs of whatever exists on the internet, such as social, Facebook, Twitter, LinkedIn, Dropbox, Google Calendar, Drive, Maildocs, and then things like Salesforce, SAP, ServiceNow, Fire. This is a specification for reading and writing medical data in the USA. Quite new and important. And then there's GitHub, Jira, Telegram. Okay? And some funky things like reading and writing barcodes, several kinds of encodings, templating engines, and scripting languages. You can use scripting languages to transform your data, for example. And then there's these Kubernetes and containers related things. So you can listen on events of a Kubernetes cluster and do things that you need, right? So to define these integration routes, one uses domain-specific languages. There's several of them, and the most usual one, or the most commonly used, are Java and XML. The functionality is basically the same in all of them. In Java, you would use this Fluent API, where you first name the connector, the component from which you are, in this case, polling the data. These are keywords that you are interested to pull through the Twitter API. Then you log something so that you see that it works, and then you simply push, without any transformation, all the Twitter messages to a Telegram bot. Here is missing what kind of bot it is. because it would be too long to specify the ID and the credentials and so on. So in XML, it's much like the same, and you can do this in Groovy, Scala, Kotlin, JavaScript, and maybe some more languages like Ruby. Okay? So Apache Camel is basically a library that can be embedded or used on many different platforms. Nowadays, it's probably Spring Boot is the most common. Karav is older, that's an OSGI container, and Wildfly is exactly the piece I'm working on. So if you like traditional Java EE, you can run Camel on top of Wildfly or JBoss EAP. Except for that, you can produce a jar that is directly runnable with java -jar. And as you may have heard yesterday, there was a talk by me about Quarkus. It's a new platform for writing cloud-native, very fast and small applications. And there's some basic support for Camel there already. There's still a heavy development happening in Apache Camel. Currently, the major version is 2, and the version 3 is in works. It's to be expected around September 2019. There's some tidying up and cleanup going on. Deprecated things are going to be or are being removed, but the backwards compatibility is kept as far as possible. The Camel core is rewritten a bit to be more modular and to be more lightweight. There is something called Fluent Builder Endpoint Configuration. As I've shown on the slide before, you would typically nowadays configure your components, the connectors, using plain strings. When you just put those configuration parameters using the @ and equals notations like in URLs. And there's which is not type safe, and there's going to be a Fluent API for it. So there's some new enterprise integration patterns coming in. Java 11 support is planned, and new website documentation and those Quarkus extensions I mentioned already. And Camel K, which is the second most important, the second part of this talk. So, if you have a mobile phone and a network connection, if you could please tweet something about Camel and this official hashtag of this conference, so that we can test if a simple integration pipeline works. So this is gonna poll on Twitter and send the messages to Telegram. It's a traditional Spring Boot application. Let me show what the source looks like. This is the... I hope you can read it like this. This is the main, which is nothing special. Then here is the roots definition, which is the interesting part. We define 2 roots, and one of them is the main one, which polls Twitter every this many seconds, and this many gets resolved from the properties file in resources. This many is 5,000 in our case, 5 seconds. Okay. And these are some credentials for Twitter API, and we are looking for these keywords that I mentioned, right? So if you tweet something, we should see it in the Telegram room when we run it. So we also do some transformations using these processors. We have two of them because we are on Spring Boot. We can use Spring dependency injection, and this processor is doing the only and simple thing that it transforms every of the keywords that we specified to uppercase so that we can see them better. The second transformer, the second processor, is there just for you, if anybody of you wants to join the Telegram room, so that you see the messages as well. This processor will listen for new people joining the room, and so that it can then dispatch the messages to every one of you. So this is the ancillary route. That's basically it about it. I will show you how it works on OpenShift when all demo gods are with me. I had some problems starting the cluster. Hopefully it's going to work. So I should be there where I hope I am. I should be able to push to Minishift, which is the local cluster running on my machine. It says everything up to date, and it hopefully already, the sources should be already there inside the cluster. Inside the cluster I have a Gox repository. Gox is a simple UI for Git that is very easy to deploy on Kubernetes on OpenShift. And I have pushed into this internal cluster Git repository because I have a Jenkins file in my source tree. OpenShift automatically understands that I want to run these this Jenkins file using Jenkins, and it should spin up a Jenkins instance for me, and I should see a pipeline having run here, which succeeded. We can have a look at the log if it really succeeded. That looks like that. So the pipeline should be running, and if I now look into this Telegram room, I should see something, but I don't see anything, even though I tweeted earlier today my slides, which you, by the way, can find on my Twitter. Slides here. It contains camel and a hashtag, so we should probably hopefully see it. But we can have a look into the console of the application. The application is in a separate namespace called something prod, which means basically production. We can have a look at the log of the pod, and something wrong is happening there. What's the matter? I have tested too many times today, and I have reached the limits of the free API, which I am very sorry, and you won't be seeing any messages forwarded today. I'm really sorry. Maybe I should have several accounts ready for situations like this. But if it worked, you would see at least my message appearing here in the Telegram room. So these ones are old, my old test messages. So okay. So this was the traditional way of deploying camel routes. What's the time? Time is okay. What's the problem with it? This pipeline on Jenkins took how long? Pipelines. It's the wrong namespace. It's here. Builds pipelines. This pipeline needed 4 seconds plus 36 seconds, which is 40 plus 19, around a minute to finish, which is not bad for a Spring Boot application, including building a Docker image and the whole application and booting it. But it's still too long, and we have used Fabricate Maven plugin to build the image, which is defined here directly in the POM in a special profile for OpenShift. Here at the end, here's the plugin in OpenShift profile, and that's what the Jenkins pipeline was running. And this module invocation just installed or just pushed the OpenShift image, the Docker image, to the internal registry inside my cluster, where it then was started from. So the minute is not bad, but maybe not ideal. What can be done about that? There are two new areas where the speed matters, and matters a lot. One of them is low-code and no-code integrations platforms, such as Synthesis, that our Red Hat Fuse team works on. These are meant to be used by so-called citizen integration developers, which are not necessarily engineers. This might be sort of technical people, but not necessarily software engineers. And it should be easy for them to click a simple integration pipeline together, and they basically want fast feedback. That's the first use case for fast pipelines, fast deployments of pipelines. And the second one is serverless functions. In that area, you want a piece of code to be executed very fast, even though it's new and it's a cold start and it happened for the first time. The area of serverless functions is very interesting for Apache Camel, because that's basically what Camel did all the time, doing simple things and integrate other complex systems, and we just want to be there. Maybe you heard about Knative. Who heard about Knative? Knative is a set of components that are there to provide basics for serving serverless functions on Kubernetes. So that's exactly the area where Camel K is targeting. So in these both areas, we need fast prototyping, rather simple business logic. If there's no CDI or no whatever exists on Spring Boot or traditional Java EE, it doesn't matter, because the citizen integration developer wouldn't be able to click it together through the UI anyway, right? And in the serverless functions, it doesn't matter anyway, because there the environment is supposed to be small and the dependencies are not supposed to explode. So it's rather important to get fast feedback than too much complexity. So that's where Apache Camel K wants to go for fast development of simple routes. It started around the end of August last year, and I will show you a demo first, and then I will explain how it works. So here I need to switch to another revision of my repository. Reset hot. And this is the simplified version of the same route. Before we had several Java files here, and they were tied together using CDI. Now we have just one file, which is the design limitation of Apache Camel K, and the one file contains everything we need. It happens to be a Groovy file, but it could be a Java file or whatever other languages are supported at the moment, like JavaScript, I think. So we have the same functionality here, but it's simply not so many files. We have inlined the processors. I got a message. Camelbot. Oh, it succeeded now. Look. Maybe I just kill the container so that it doesn't spend the limit, and again I just scale down to 0. Okay. So we have everything in a single file, and it's the same functionality as I have shown you before. This is the first route, and here is the second route. The transformer that is uppercasing is here inlined, and the second one that is registering the chat members is inlined as well. To deploy this, we are not using any way to produce a Docker container. We use a special client tool called Camel with K. So this is it. To get Camel, you simply go to Camel K GitHub repository. The link will be there in the presentation later. You download the binary distribution, unzip it, and add Camel binary to your path so that you can use it. Then you need to install it inside your OpenShift or Kubernetes cluster. To do it, we will create a new namespace, which is new project command with OC and namespace something with Kubernetes. New project Camel K, which probably exists already. Yes, it doesn't matter. So we just switch to the namespace. Project Camel K, and we install Camel. Install. So Camel is there, and what we can do, how can we push the root definitions to the cluster? Simply using Camel run. Camel run. This is the correct path, and we are using Kubernetes secret, which is just a holder of some of a properties file that contains our Twitter and and Telegram credentials. I have created the secret before, so that I'm not boring you with OC commands. So when I spin up this, we should wait some time when it's first time started, but after maybe tens of seconds we should see the container to be there. So this is the operator. I will give you a short introduction to Kubernetes Operator in a few minutes. And this is this? Yes, it must have started already because we got the Telegram message. Testing Twitter to Telegram. Can you see it? I have killed the old container, so this is surely the new one that I just started. So I have started this in development mode, so that when I do some change here in the code, for example, instead of uppercasing, I will do what? I will add something like a star before. I'll save, and the binary Camel K is watching for the changes in local files, and if it sees a change, it pushes the changes, and the message is there. A couple of seconds. Could you see it? And now we should be getting the message with the star, but I don't see it. What happened? Let's do something else, like this one. Still not there, but it's apparently working. I don't know. Let's try lowercase. So it's deploying, and the feedback is quite fast, as you can see. Camel presentation. Still doesn't work. I don't know. Camel. For which reason? So this is how it works. So the redeployments work apparently. If so, now let's get back to the presentation and explain what's there behind it. What kind of technologies here. So first we have seen the Camel client binary that you can get from Camel K releases. There's a Camel K operator in game. What it is, we'll explain just now. Camel K operator, Kubernetes operators in general are an application management concept. Who of you has ever heard of operators? Nobody. Very good. So what a human application operator, it's ops, right? Ops are those people who are taking care for running software. What such a human ops man would do is now done by these automatic operators, right? How are they doing it? And it's important to know that this is rather a usage pattern of Kubernetes than some sort of software there. You could do operator pattern since day one of Kubernetes, because an operator is basically just a running container that does something. It implements some logic that takes care for running your application. Okay? So that's it. And how it works? There's something like Kubernetes API inside the cluster, where you can ask for existing pods and existing services and existing whatever, and you can listen for changes too. So the operator registers some hook, and Kubernetes cluster sends notifications to the operator. And as I said, operator is just a running container. And inside that container, there's some custom logic implemented that takes care for how your application should work. And what this custom logic is implementing is basically up to you as an author of an operator. There can be things like scaling up, depending on metrics that you have. That's very typical use case for operators. Things like backups of databases. Things like I have forgotten what. Sorry. Scale up and down, checking things, and so on. Very important part in all of that is that for an operator, so that an operator knows what it should do, sometimes it needs an input from human. For example, that you want to deploy a new version of the application, something like that. There were always means to do this inside Kubernetes. You could use config maps for that. But since Kubernetes 1.7, there is this concept of custom resource definitions, CRDs. Inside Kubernetes, you have built-in resources such as pods, services, and you can OC create pod, OC get pods, OC delete pod. And you can now do the same things with custom resources that you define yourself. You defined like an object, what fields are there, and you can create, delete them. That's basically storing data, some configuration data inside the cluster, which your operator reads and gets notified about changes because it listens on the Kubernetes API, and it does some actions and reacts. Okay? And how is all of this used with our inside Camel K operator? So on one hand, we have the definition of the root, which we have seen. It was a GUI file. And that GUI file is watched by the Camel binary. And if it changes, a custom resource definition of type integration is created. And that collects some metadata about the root, right? And once Camel binary creates the custom resource integration, our operator, which is a running container, we could see it here on the console. It's running here, it's there, it's a container. It gets notified and it does some actions. It analyzes, okay, what's there for metadata about the new root, and it creates some more custom resource definitions for its own convenience. And then, based on that, it spins up those traditional built-in resources like images and config maps and deployments. And our Camel K operator, as we have seen, it has spun up a container that was serving our integration route. And all of that takes a couple of seconds, which is nice. But this wouldn't actually be enough to get these little seconds. There is a bit more tricks inside that. So, first of all, the operator looks at which language is there in the root definition. And based on that, it chooses a set of jar dependencies that are needed by that root definition. So if it's Java, there are some definitions. If it's Groovy, it probably needs some Groovy runtime or whatever, and the same for Kotlin and Spring Boot and so on. So given this, we have got some set of dependencies that is needed to serve that root. And we basically need to create a container that has those libraries installed. But that was just the base, okay? The language decides a set of dependencies, but based on what's there in the root definition, if it's Twitter or Telegram or whatever else, there are some more dependencies coming in. So it adds dependencies again, and this is the moment where it either builds a new image that contains all those necessary dependencies, or it reuses an image that is already there from the previous iteration. And how can we do that? Think of it. We can do it only because the root definition isn't considered a part of container. And this is, I think, very nice trick. A root definition is just mounted as a config map into a running container. You typically consider Groovy scripts part of the source code, of the code that is supposed to run inside the container, and you put it there as a layer or something like that. And Camel K operator is tricky enough to ignore this and consider the root definitions as just a configuration, actually, which is nice because it allows very fast feedback. We don't need to recreate the container with every change in the root definition. The root definition may add new parameters, add some code like transformations, uppercase, lowercase, things like that, and that wouldn't change the image that is used to run that root. And this is exactly where the fast feedback comes from. Sometimes we don't need to rebuild the container because rebuilding container takes a long time. Okay? What are the limitations? It's nice that it's fast, but it's not 100% replacement for Apache Camel for reasons you have seen. There's no CDI. All definitions need to be in a single file, and so on. Second, this is sought for fast prototyping, and there's no built-in way to test it. You probably just need to have some sort of integration tests fully outside of this, or maybe you need a pipeline or something. Okay? That's basically it about Camel K. There's just a few things I want you to remember about from this presentation. It's an operator-based Kubernetes runtime for Camel. It allows fast prototyping, and it's for roots with simple or no business logic. If you are interested, these are the important links where you need to go. As I said, I have posted the slides on my Twitter, and if you find me on Twitter, you will see the slides there. Feedback and contributions are welcome. You may want to follow these two guys who are the main developers of Camel K, and the mailing list to discuss is here, and the chat to ping the people is here. Are there any students here? Because we are in Google Summer of Code, so if some of you are students, you may join and get tasks and get money during the summer months. That's it. Questions? Question?
I have a question. You mentioned that you don't need to rebuild the image, so that stuff is pretty much in the ConfigMap. No image rebuilding, but I assume it must be something like a redeploy, so the new ConfigMap is active.
once again, so the question is
Question is, okay, if there is no rebuilding of the image, but
sometimes.
yeah, but I'll still get it. Is it just an environment variable that is changed and then the actual running container is redeployed?
Yes, always. If you change the config map, Kubernetes always redeploys.
Okay.
Never worked with Apache Camel, but I've worked with Spring integration. What made you choose Apache Camel instead of Spring integration?
I don't know. I would say, because I'm from Fuse and Apache Camel is older, bigger, better. Spring integration is new. It's a toy. You don't have 280 connectors there. I think. I have never used it, so maybe I'm fully out of picture. But Apache Camel is the standard in the area, so that's why. Another question? No one? Thank you very much. Enjoy the rest of the conference.